In the previous video, we looked at the LLDB debugger in Xcode. In this video, we're going to see how we can get the most out of our breakpoints. We'll look at a few different types of breakpoints, as well as how to run actions when our breakpoints are hit. The first type of breakpoint that we're going to look at are called conditional breakpoints. Conditional breakpoints allow us to tell Xcode that we only want to pass our session to the debugger if a value reaches a specific condition. To demonstrate this, we'll just use a simple for-in loop and we'll set a given condition. Let's create a new single-view application and name it Breakpoints. Once our application is loaded, we'll add a function named BreakpointTest. And we'll paste in a simple loop that loops through the range of our values. Place a breakpoint on the BreakpointTest function inside of the for-in loop. Next, click on the Breakpoint Navigator in the Project Navigator ribbon. Now, we can edit our breakpoint by right-clicking on our breakpoint and choosing Edit Breakpoint. Notice the condition box here at the top. You can enter any condition that results in a Boolean true or false here. In this example, we'll just write val equals 200. So this breakpoint should only fire when our value is equal to 200. Build and run, and let's see if it fires as expected. Our application breaks, and we see in our console window 200 print statements. Let's stop our application and edit our breakpoint again. This time, let's stop it at 2000 and see if our application breaks. This time, our application continues to execute as expected. One thing that you may have noticed while running our application with this conditional breakpoint is that it runs very slowly. It takes over 5 seconds to iterate over 2,000 values. This is because Xcode turns our application over to the debugger every single time it evaluates. Another thing that we can do with breakpoints is to define an action to be carried out when our condition is met. Let's right-click on our breakpoint and select Edit Breakpoint. We'll change our condition to val greater than 900. Next, click the Add Action button. This reveals an input box which allows us to enter debugger commands, which we'll cover in a later video. For now, we'll just add the following LLDB command, printVal, which will print out each value that meets our condition. Before we run, check the Automatically Continue After Evaluation Actions checkbox. Build and run the application, and we'll see our values slowly iterating through our range as expected. Once we pass 900, we start seeing additional print commands firing in the LLDB output window. Another type of breakpoint we have at our disposal is the symbolic breakpoint, which allows our breakpoint to be triggered every time a given function is called. The function does not need to be in our own source code either. We can also break on system and third-party framework code. Before we get started, let's add a function to our program named SumFunction that has a simple print statement in it. Then we'll update our loop with a condition. If our value is equal to 950, then we'll fire our SumFunction method. Setting up a symbolic breakpoint is a bit different than setting up regular breakpoints. Rather than setting our breakpoint in our editor, we'll click the Breakpoint Navigator button in Xcode's Project Navigator ribbon. Then, click on the plus icon in the bottom left of the pane. Find Add Symbolic Breakpoint from the dialog and select it. You'll see a blank breakpoint appears along with a dialog. The first input box allows us to specify a symbol. We'll add viewController.SumFunction to specify our new function. Of course, we've got access to conditions, actions, and we can even specify a module for our scope. For this example, we'll just use a symbol. Now that we have our symbol, let's build and run our application. And we see our breakpoint triggers right when our loop hits 950, and our SumFunction method fires. Let's look at one more type of breakpoint, which is the exception breakpoint. Exception breakpoints can be tremendously useful when troubleshooting the source of an exception. We're going to update our code one more time by throwing an exception in our SumFunction method. We'll start by modifying our method definition to include the throws keyword, which tells our calling code that this method has the ability to throw exceptions. we'll raise a simple generic NS exception and add the following statement. NS exception with parameters name set to myCustomException, reason, breakpoint, set user info to nil, and then call raise to raise the exception. Finally, in our for-in loop, we'll add a do-try-catch statement that attempts to run our sum function, which, as we know, will throw an exception. We'll be taking a closer look at this type of error handling in an upcoming video, but for now, this should do the trick. Let's remove the existing breakpoint, and then we'll build and run. We see that we're taken to the app delegate, and our exception is thrown. This isn't terribly useful. It would be nice if Xcode would actually show the code that threw the exception. That's where exception breakpoints come in. Let's go to the Breakpoint Navigator and add a breakpoint. Select Exception Breakpoint, and we'll leave the defaults as is. Build and run, and you'll see that we're taken right to the source of our exception. However, we don't see an actual exception in our LLDB prompt. We can fix this by editing our breakpoint to utilize an action. In the Breakpoint Navigator, right-click on the exception breakpoint and select Edit Breakpoint. When the dialog appears, click the Action button and add the following LLDB command, PO, and then inside of square brackets, $arg1 name. This retrieves the name of the thrown exception. If we build and run our application, we see that our application breaks at the exception's origin and prints out the name of the exception. I haven't covered all of the different breakpoints here. We also have access to Swift error breakpoints, OpenGLS error breakpoints, and test failure breakpoints. You can visit this video's resource page for more information on breakpoints. In this video, we have seen multiple ways to enhance our breakpoints. In the next video, we'll introduce the LLDB command language.